Assalamualaikum and good evening everyone. Okay, first of all, I'm sorry for the delay. We are about 13-minute delay from the schedule due to I have faced some problem with my computer. But I hope you still there waiting for this class. Okay. And as I told you earlier in our previous lesson, today we are going to continue with our discussion revision for your SPM. And for today, we are going to try to finish paper 1. We have 10 more remaining questions to go. And then later we will proceed with paper 2, section A, 8 question on structure. So I hope you are all ready as we are about to begin soon. I believe this morning you have went to school to get all your modules for all subject. And remember, this is actually the MPSM, Majlis Pengetua Sekolah Malaysia, sets by Cawangan Pulau Pinang. And all the questions that's set for every subject is actually the topics which are targeted for this year, SPM for this year. Okay. So let us begin our discussion with paper 1. Okay, before that, can you respond to me if you can hear me clearly? You please type on the live chat if you can hear me clearly. Please type there clear. All right. Okay, so I hope you have your module with you there. So this is Penang State SPM Trial 2020, question paper 1. So we continue with question 41. Okay, question number 41. This question is on electromagnetism. Okay, thank you Jinji and Vinci. Okay, so we proceed with question number 41. Okay, you are given, okay, thank you Wei Liang. You are having diagram 32. Okay, this diagram shows a coil of wire is wrapped around a soft iron rod. So this is our soft iron rod is wound with the copper with the coil of wire. The question is, which of the following statement is true? So you are given 4 statements A, B, C, D for you to determine which one is true. So if you refer to this diagram, this is the position of our cell and this is the rheostat. This is the solenoid. Okay, so which one is true? A, B, C, or D? A say the strength of magnet decrease by increasing the resistance of R. Is that true? When we increase the resistance of R, the strength of magnet decrease. Okay, and then B, and Y of the rod behave as the north pole. You say Y is the north pole. The polarity at the end of the rod depend on the strength on the current in the circuit. Was that true? Or the answer is D. And Y of the rod behave at the south pole of the magnet. So actually, if you look at the statement, there are 2 statements which you can reject. The first statement, which is totally wrong, and also the third statement, which is C. Okay, because the polarity, it does not depend on the strength on the current. So it is either B or D. Look at NY. NY, it is north or south pole. So how to determine either Y is north or south pole? So what rule we can apply here in order to determine the polarity at NX or NY? Can you type the rule which we can apply here to determine the polarity at Y? What rule can we use here to determine polarity of X or Y? It is, okay, please type your answer in the live chat. What rule we can apply, which rule we can apply to determine the polarity at X or at Y? Yes, it is. Okay, this is the direction of current flow. Vinci say right hand grip rule. Yes, Vinci, very good. Before that, if you look at this diagram, this is how the current flow in the circuit. And along the coil, how does the current flow? The current flow in this direction. Okay. the current flow in this direction. So applying right hand grip rule, how should we hold this rod? So imagine, okay, you can take your pen as the rod and try to hold it with your right hand grip rule. Okay, right hand grip rule. So the arrow along the coil show your forefinger, mean your forefinger must be curled downwards. Okay, it show the direction of current is downward. So you will find that your thumb will be pointing to the right. Okay, thumb pointing to the right mean pointing to Y. So thumb pointing to the right, it shows Y is north or south. So which one is the answer, B or D? Thumb pointing to the right, applying right hand grip rule. So it shows us that NY is a north pole. Okay, NY is a north pole, while NX is a south pole. So the answer is boy. Okay, NY of the road behave as a north pole. Okay, next, question 42. Okay, question 42, look at diagram 33. This is a question on 3.4, transformer. Okay, you are given diagram 33. It shows a transformer consists of a primary coil with 1000 turns. Okay, and a secondary coil with a total of 100 turns, which can be adjusted at various positions. Okay, so which pair of terminals should be connected to a 12 volt 24 watt lamp for it to be lit with normal brightness? So if you connect a lamp at the outer circuit here, at the secondary circuit, in which terminal we should fix the lamp at? Which pair? Is it between, you're given 4 choices here, PR, okay, PT, QS, or RT. Okay, if you look at our secondary voltage, it consists of a few pairs of terminal. Normally, you look one output voltage only, one secondary coil only, but now it is divided into a few sections. In between PQ is 20 turns, in between QR is 20 turns, in between RS is 30 turns, and in between ST is 30 turns. So I zoom in the diagram for you. So this is our primary voltage, 240 volt, which means the external voltage or the secondary voltage is 12 volt. Okay, is 12 volt 24 watts. So how to determine which pair is suitable for you to fix the lamp at? So it will lead with normal brightness. Normal brightness means it will lead at 24 watt. Okay, so we apply this formula for transformer. Vinci say 42 is C. NP divided by NS equal to VP divided by BS. So we place the substitution. NP is 1000. NS, we have to determine which one is a suitable. VP primary voltage is 240 volt and the secondary voltage is 12 volt. So by this, it will give you NS of 50 turns. So we go back to the pair. Which pair will give you 50 turns? Okay, which pair? Look at PR. PR is 20, so 40 turns. So wrong. PT is 100. Okay, 100, the top end to the lowest end, the total 100. So this is also wrong. Okay, while QS, before that we look at RT. RT will give you 30 mean total of 60 turns. So also wrong. So the answer is QS. Look at QS. QS is 20 turns plus 30 turns. So it will give you a total of 50 turns at the secondary coil. So this is how we determine the suitable pair to be connected to the lamp. All right. Okay. Very well. For those who are answering C, very good. Okay. Now 43. Okay. 43 is a common question. I believe you are familiar with this question. This is a diagram 34. It shows a national grid network. It's a network of electrical cable connecting electrical power station to the consumer of electricity. So the question is, which of the following is a characteristic of the national grid network in the electricity transmission? So all the answers are very long, so you have to read them carefully in order to come to the correct answer. So look at A. It says electricity can be transmitted at low potential difference during peak hours of electricity usage. Is this true? This is wrong. Why? Because they're low potential. It is actually sent at a high potential difference, high voltage. Okay, now look at B. The whole country's electricity supply will be affected when one power station breaks down. Is it true? The answer is wrong, because if one power station is breakdown, okay, the electricity will be supplied from another station. Okay, C. During non-peak hours of electricity usage, the operation of some power station cannot be stopped for repair and maintenance purposes. Is this correct? Mana yang silap? Silap dia di sini. Cannot. Supposed to be can. Okay, can be stopped for repair and maintenance during non-peak hour. Okay, so which means the answer is D. Some power station can be closed during non-peak hours to cut costs. Yes, this is what we do. Okay, so the answer for 43 is donkey. Alright. Okay, now let's take a look at question number 44. Okay, 44 is on oscilloscope, cathode ray oscilloscope, CRO, sorry. Okay, diagram 35 shows the structure of CRO. So I zoom the diagram for you. It asks, okay, you're given four structure here. It labeled four structure A, B, C, and D. Okay, so the question is, which component A, B, C, or D causes the electron to accelerate? So which component? So for this question, you have to know which part of the CRO which act to accelerate the electron. So what are the name of those parts which is used to accelerate the electron? What is the name? Can you type the name of those parts which is used to accelerate the electron inside a cathode ray tube? Okay, before that, let's take a look at the structure again. What is A? Okay, what is A? You must know the name of all these parts. A is cathode. Okay, A is cathode, where the electron beam coming from when the filament is heated. Okay, how about B? What do we call B as? B is called as a control grid, if you remember. And C is focusing anode. Okay, focusing anode which assemble the electron in one straight line. Okay, so D is accelerating anode. So D is accelerating anode which accelerate the electron to the front part of the cathode ray tube, which means the answer is donkey. Yes, answer is donkey. Okay, now 45. Question number 45. Okay, 45. You are given diagram 36. It shows an automatic switch circuit to light up a bulb at night. Okay, you highlight. Okay, automatic switch, light up bulb at night. Okay, so the question is, what changes should be done to light up the bulb during the daytime? Mean what modification must be do so the bulb operate in the opposite way. Okay, if you look at this diagram, okay, now the variable resistor is placed on top and the LDR is placed at the base circuit. And in this position, it operates at night. So if you want to change the operation, so it will switch on at day, which means we must interchange the position of these two, R1 and R2. So which one is the answer? A, reverse the terminal of the battery. It doesn't help at all. C, replace the NPN with the PNP transistor, that will be not help. Or also D, replace resistor R3 with resistor of lower resistance. So the answer is B, interchange the position of R1 and R2. So it will be operate at the daytime. Okay, question 46. Okay, diagram 37 shows a circuit consisting of a diode and a bulb. Okay, and when the switch is on, the bulb does not light up. Okay, you can highlight switch on, bulb does not light up. So the question is, what need to be done to light up the bulb? Okay, so before we go to the options of answer, let us study this circuit 37. Okay, now the switch is in open position. Open means switch off. Okay, open position, switch open mean it is switch off. So no current flow. When you close this switch, so the circuit is open. The circuit is closed. So current will flow in which direction? Current flow in this direction. So now the diode is in a reverse bias. Okay, the diode is now in a reverse bias. As current flow in this direction, it cannot pass through the diode. Why? Because it is in a reverse bias. So what can we do so the bulb can light up? A, wrong, nothing to do with the bulb. The bulb is just okay. Increase the number of dry cell is not helping. Connect a resistor parallel to the bulb also doesn't do any change. So the answer is reverse the diode connection. Yes, Arifah Haminuddin. Answer is C, reverse the diode connection. Okay, before that, for those who are not from Bagan Jaya, I have prepared the question sets in the comment section and in the video description, so you can get them from there. Okay, thank you very much for joining us. So answer is C. Okay, now 47. 47 is on logic gates. All right, diagram 38 shows combination of 3 logic gates. So this is our gates. We have input P. Can you name the name? Can you tell me the name of this gate which we fix at input P? What is the name of this gate? It is a triangle with a circle at the front. Okay, and then input Q, we have this gate. And gate X is missing. Okay, and this is our output R, diagram 37. Together with the diagram, you are given the truth table. Okay, the truth table shows to us the input at PQ and the output at R. And this is all the possible reading for the input. Okay, 0, 0, 0, 1, 1, 0, 1, 1. All the possible pair for input P and Q. And this is the value for the output given, which produce at R. Okay. So you are asked to study these two diagrams and determine, okay, the truth table for combination of 3 logic gates. So which one we should place at X? Yang mana? Get tak. Okay, get tak mean not gate. Okay, not gate. Yes. Okay, not gate. So which gate we fix at X? 47. If you want to write your answer, you write the number of question only, so I can see clearly which question you are referring to. Dylan say we place no gate. Okay, which gate we fix at X? AND gate, OR gate, NAND gate, or no gate? Okay, look at the reading of the truth table. The input is 0, 0, output is 1. Okay, when the input is 0, 1, the output is 1. When the input is 1, 0, output also 1. Okay, and when input is 1, 1, the output is 0. Study this truth table carefully and determine which gate is suitable to be fixed at X. If we use AND gate, okay, if this is an AND gate, so you tengok reading ini 0 and 0. So 0 and 0 supposed to be 0, right? 0 and 1 supposed to be 0. 1 and 0 supposed to be 0. 1 and 1 supposed to be 1, not 0. So this is not AND gate. So AND gate we reject. If we say X is O gate, okay, let's say we fix O gate. So for O gate, 0 or 0 supposed to be 0, but this is 1. Okay, for O gate, 0 or 1 supposed to be 1. Yes. For O gate, 1 or 0 supposed to be 1. Yes. 1 or 1 supposed to be 1, but here is 0. So it is not O gate. It's not AND gate. It's not O gate. Okay. How about C? NAND gate. Okay, NAND gate mean we read AND first and then we read the note. Okay, we read AND first and then the note. Okay, so 0 and 0 is 0. Not 0, supposed to be 1. See, this is 1. Correct. 0 and 1 is 0. Not 0 is 1. Correct. 1 and 0 supposed to be 0. Not 0 is 1. Correct. 1 and 1 is 1. So not 1 is 0. So it is actually NAND gate. Okay, so answer is NAND gate. NOR gate also wrong. Okay, so 47 ini answer is NAND gate. If you place NOR gate here, so what should be the reading? NOR gate. NOR gate we read O first and then we read the note. Okay. So if you place here NOR gate, the reading supposed to be like this. 0 or 0 is 0, not 0 is 1. Okay, this one is correct. 0 or 1 supposed to be 1, not 1 is 0. This is wrong. 1 or 0 is 1, so not 1 is 0. So this is wrong. 1 or 1 is 1, not 1 is 0. So the reading number 2 and 3 is wrong, so it is NOR gate. So the reading that fulfill all the output is NAND gate. So for 47, I didn't see anybody answer correctly. Vinci say B, Jinjie say A, and then later Vinci say D. It is actually C. Vinci, okay, the rest of you. So are you clear? 47, why the answer is C? Why the answer is NAND gate? If you clear, you can type yes in the live chat comment. Okay. 48. Okay, now 48. You are given diagram 39. 48 is on radioactivity. Why cannot O gate? Okay, we go back to the question, Vinci. Okay, you look at the truth table. If you put O gate, so for O gate, okay, this is the reading that you are given. Okay, if you put O gate, so 0 O 0 supposed to be 0, but here is 1. So it doesn't match with O gate. 0 or 1 supposed to be 1. Okay, this is correct. 1 or 0 is 1. Yes, this is correct. But the fourth one, 1 or 1 supposed to be 1. But here it is 0. So we can place O gate there, Vinci. Okay. It must, the gate that you place there must be come to this final answer for all 4 pairs. It must match all the output, all the reading at the output. For O gate, it only fulfill the first and the fourth combination, but it doesn't match with the second and third reading. Jinjie teacher, does the NOT gate have effect? Can NOT gate, if you place NOT gate, we don't have NOT gate there. Which NOT gate you refer to? Yang atas. Okay, ini you tengok sini. This 38 ini is the circuit and the truth table ini is the result, is the come out. So we refer to the truth table to determine which gate we should place here. So the suitable gate to be placed is a NAND gate. So for this question, you don't get confused, class, because it say here, above is the combination of the 3 logic gates. And then down here, it say the truth table for the combination of the 3 gates are as follows. So we follow the truth table combination to determine which gate is supposed to be placed here at X. Okay, are you clear? But they have not gate before or gate. You refer to this diagram. As I said, as I say to you just now, okay, so if you read the question carefully here, the truth table for the combination of the three logic gate are given as follows. So this is the result given. Okay, so we must see which of these four options match, okay, with the truth table given here. Okay, so this is our output coming at R1110 as shown in this table. 1110. So which gate we place here will give you 1110. So that is NAND gate. Okay, the answer is NAND gate. Okay, thanks teacher. Okay, Jinji. Okay, never mind, later you go and study back this question to get a clear understanding on them. Okay, we go to question 48 now. All right. Okay, this is on radioactivity. Okay, you are given diagram 39. This is quite easy. The question is quite simple. It shows a path of radioactive ray S and T. We have two radioactive ray S and T, where we place a paper, aluminium foil, and lead plumbum. Okay, normally when you see this setting, so this setting normally show the penetrating power. Okay, the penetrating power of the radioactive ray. So which ray represent S, which ray represent T? They give you A, S is alpha, T is beta. For B, they give you S is alpha, T is gamma. For C, S is beta, T is gamma. And for D, S is gamma, T is beta. So which one do you think S and T? A, B, C, or D? Look at the diagram 39. Okay, diagram 39, it shows ray S can be blocked by paper, while ray T can pass through paper and aluminium, and it is blocked by lead plumbum. Okay, so the answer is B. Okay, answer is B. S is alpha and T is gamma. Okay, very good. Answer is B, boy. Yes, Yizen, it is boy. All right. Okay, now question 49. Okay, class, question 49. For those who have tried, I think you have some difficulties in finding the answer because actually the diagram given is not correct. So first and foremost, I want you to make a correction on diagram 40. Tolong buat pembetulan. Diagram ini ada sedikit kesilapan. Up here is not 1000 as stated. It is actually 800. Okay. And here is 400. So the 500 you delete, you erase. And down here is 200. The time here is 15 minutes when the sample, when the activity is 400. And when the sample or activity is 200, the time is 30 minutes. This is the correction you have to make for this diagram 40. Okay, please make the correction first. Okay, so the question is, diagram 40 shows a decay curve of a radioactive material. So what is the activity after 1 hour? So after 1 hour mean how much sample left? So we know this sample undergo radioactive decay. So after a few while, after 1 hour, what will be the number of sample left? So we say what is the amount of activity left after 1 hour. So please calculate. For those who are not doing yet, I give you a few seconds to try on it before I show to you the solution. 49, what do you say? What is the activity after 1 hour? B, Jinjie say B, 100. Okay. Any other answer? Okay, before that, again, please do the correction on the diagram 40. Tolong betulkan diagram ini. Up here supposed to be 800. Here is 400. So 500 itu no more. You can delete. And down here is 200. And the time here is 15 for 400. And 30 minutes for 200. Okay. So what is the activity after 1 hour? So I give you a clue for this kind of question. You find the half-life first. Okay, what is the half-life of this sample? Chi Aying say A. Can you tell me what is the half-life of this sample? What is the half-life of this radioactive material? Kita tengok graf ni, you boleh tahu dah half-life dia berapa. The half-life is determined when the sample, which is initially at 800, reduced into half, mean reduced to 400. So the time at 400 will give you the half-life. So the half-life is 15. Okay, this is the initial content when time is 0, 800. And after 15 minutes, the sample has reduced to 400, mean reduced by far, reduced by half. So by this, we say that 15 minutes is the half-life. Okay, 15 minutes is the half-life. So you are given 1 hour. So in 1 hour, how many half-life involved? Yes, Jinjie, then half-life is 15 minutes. In 1 hour, how many half-life involved? It is 4 half-life. Okay, so if you solve mathematically using this expression, this is what we will get. Okay. N ini number of sample left after 1 hour. Divide by 800 ini is the initial content. And then equal to half. 4 ini is the number of half-life. So now we have 4 number of half-life. So it is, we place 4 here. So to find N number of sample left after 1 hour is 50. Or you can do it by showing the flow chart. Okay, 800 reduced to 400, this is the first half-life. And 400 reduced to 200, this is the second half-life. 200 reduced to 100, this is the third half-life. So 100 reduced to 50, this is the fourth half-life. So the final remaining sample is 50. So answer is A, 50. Okay, that is how to do 49. Okay, then question 50, again on radioactivity. This time you have to calculate the energy released in the reaction. Okay, first of all, you are given this equation represent a nuclear fusion. Okay, what is the meaning of nuclear fusion? Fusion means combine. Okay, mean combine. Two lighter nuclei combine to form a bigger daughter nuclei. And this process release a very enormous amount of nuclear energy. The amount of energy produced by nuclear fusion is bigger. Okay, it's bigger than the amount of energy released in nuclear fission. That one you must know. All right. And also given the value for one atomic mass unit equal to 1.66 times 10 negative 27 kg. So we have, this is the isotope for hydrogen, deuterium combined with tritium, another isotope for hydrogen. It form a helium. Okay, it form a helium, and in this process release one neutron and energy. Okay. So we want to know this amount of energy produced. They give you the mass defect from this reaction is 0.018863 AMU. They give you already the number of mass defect. They only want you to find the energy released in the reaction. So what formula we are applying in order to determine the energy? Can you type the formula we are using to calculate energy? Nuclear energy. What is the formula we are applying here? Okay, anyone? What is the formula we are applying here to find the energy release in this reaction? It is Yes, it is E equal to mc squared. This is a formula we apply to determine energy release in nuclear fission or in nuclear fusion or in radioactive decay. Alright, E equal to mc squared. So we just do the substitution where M, remember M must be in kilogram. So you are given 0.018863 in AMU, so it must multiply with the 1.66 times 10 negative 27 to convert it into kg. Don't forget that. And multiply by C square. C is the speed of light. Okay, speed of light as the energy release will be move in the speed of light. So don't forget the square as well. So by this, if you calculate, yes, Arifah, it is E equal to mc square. Yes, Chin Wei Lun, very good. Yes, Bin C. Okay, so by this, we find the energy is 2.818 times 10 negative 12 joule. So whereby answer is boy. Can you check for me, is this answer correct? Did you get 2.818 or you get 2.82 is the same? Okay. 2.82 times 10 negative 12 joule is the answer. And if this question come out in the structure or essay, please don't forget to write the unit for the energy. Okay. So answer is boy. 2.82 times 10 negative 12 joule. Okay, so I think that's all for paper 1. We finished discuss all 50 questions. So I hope you are clear how to solve all problem in paper 1. And now let us move to section A. Okay, yes, Vinci, the answer is B. Thank you for checking. Okay, now class, let's go to paper 2, section A, structure questions. Okay, may I know who, anybody has tried to do question 1 until question 8? Anyone? Anybody have tried do this question earlier? Okay, let's check the answer together. If you have done them, you may check your answer, either how much you can score, okay, and which part you get it right, which part you get it wrong, and later you can make a correction on them. All right, question number 1. So we have diagram 1, it shows the use of a transistor in a circuit. So this question is referred to electronics. Transistor in a circuit. Okay, so this is the diagram you are given with. This is the transistor. Okay, here is R1 and this is R2, which is placed in the base circuit. And this is our bulb and the dry cell supply 6 volt to the circuit. Okay, so first question A, name the type of transistor used. So what type of transistor we are using here? Okay, remember we have how many type of transistor? Yes, we have 2 type, NPN and PNP. So what type of transistor you can see here in diagram 1, NPN or PNP? Look at the arrow. Where does it point at? Inwards or outwards? It point outwards. So it should be NPN or PNP. Yes, it is. It is NPN. Transistor NPN with capital or small letter. Both accepted. Okay, transistor NPN. Capital or small letter. Transistor NPN. Or you just write NPN. No problem. Okay. And then B. The transistor is switched on when the base voltage V2 is greater or equal to 2 volt. Okay. So the question is, calculate the minimum value of R2 when the transistor is switched on. Okay, yes, NPN. Correct. So look at B, the transistor is switched on when the base voltage V2 is greater than or equal to 2 volt. Calculate the minimum value of R2 when the transistor is switched on. So how to do this? How to solve these questions? Okay, you go back to the circuit again. So this is our potential divider. Okay, How much voltage supply to the potential divider? We supply with 6 volt. Okay, we supply with 6 volt to the potential divider of R1 and R2. So R1 is given 1500 ohm. So you have to find what is the value, the minimum value for R2 when the transistor is switched on. So how to do this? You can use the equation represent the voltage and resistance at the potential divider. The formula you can refer in your module. Apa formula yang kita guna? What formula is applied here for question B? This question allocates 2 marks, 2 markah. Okay, so this is the equation which you can apply. Okay, where V squared, the base voltage, divide by V. V ini is a total voltage supply, which is 6, equal to R2, the resistance, okay, at the base voltage, divide by the total resistance at the potential divider, R2 plus R1. Okay, then we do the substitution. Okay, V2 it say equal or greater than 2. So we write there 2, V2. And total voltage supply is 6. Okay, given. R2, we want to find where R1 is 1500. Okay, so by this, please calculate the value for R2. Okay, please find what is R2. Okay, I give you a few seconds for you to find what is R2. If you have find the answer, please share with your friends. Okay, so the answer is R2 is... Anyone? Are you done? Okay, let us check the answer together. Okay, I can see somebody is typing there. So the answer is 750 ohm. Okay, so R2, the minimum value for R2 is 750 ohm. Okay, so this is the final answer. 750 ohm. Okay. So that goes for B. Okay, now C. Besides being used as an automatic switch, state one other user of transistor. Okay, this transistor, it has more than one users. Either than act as an automatic switch. Okay, what else can we use transistor as? 500. It's 750. Dear, sorry, I can't read your name because it is written in Chinese. Can you identify yourself, please? Thank you. It's not 500, it's 750. Okay. Please do the calculation carefully so you will come out to the correct answer. Okay, now for C. Anyone beside being used as an automatic switch, state one other user of a transistor. 1 mark. Current amplifier. Okay, so let's check. Yes, Ginger, very good. It is used as a current amplifier. Okay. So that goes for question 1, 4 marks. Okay, question 1 ini is actually question 1 in section A. Question 1, remember it allocate 4 marks. Okay. Second, ini question 2. Question 2 allocates how many marks? 5 marks. Alright. Okay, now in diagram 2, it shows a bulldozer of mass 7,000 kg is moving up a slope. Its speed before moving up the slope is 35 meter per second. So this 35 meter per second represent the initial velocity. Okay, before moving up the slope is 35 meter per second. Okay, question A. State the energy changes when the bulldozer moving up the slope. Okay, what kind of energy changes occur when the bulldozer moving up a slope? What energy convert into what energy? What energy changes into what energy? Okay, type your answer now. A. It's a very basic concept, changes of energy. The bulldozer is moving from down, it climb up the slope. So what kind of energy changes occur? What energy convert into what energy? Yes, it is kinetic energy convert into gravitational potential energy due to its changes of height. Okay, kinetic energy convert or changes into gravitational potential energy. Okay, and then B. Yes, Vinci, very good. Kinetic energy to gravitational potential energy. Either you write the arrow, you draw the arrow, or you write the word to. Okay, to gravitational potential energy. Okay, and then B, calculate the kinetic energy before the bulldozer moving up the slope. So how to find the kinetic energy? Class, what is the kinetic, the potential? Please write the full type of energy, potential. Okay, because potential, we have two types of potential energy. Gravitational potential energy. Another one is in spring, elastic potential energy. So which potential you are referring to? So it is kinetic to gravitational potential energy. Okay, Wei Lun, I hope you clear. Remember, we have two type of potential. Gravitational and elastic potential, which is stored in the spring when the spring is compressed or stretched. So you must be very, very specific. Gravitational potential energy. Okay. Okay, class B, have you find the calculate the kinetic energy before the bulldozer moving up the slope? So what equation we are applying here? Kinetic energy. Okay, yes. Kinetic energy is given by half mv squared. Yes. Find kinetic energy only, Jinje. Relationship ini nanti in the next question we will apply. Okay, B ini straight away we use the formula for kinetic energy. So, half, the mass is given 7,000 kg. So, we do the substitution for M. And then V, 35 meter per second. Okay, below it move with the velocity 35 meter per second. Yes. So what is the answer? Okay, find the amount of energy. Please solve this equation. Half multiplied by 7,000 multiplied by 35 square. Okay, so answer is how much kinetic energy? Yes, it is 4.29 times 10 to the power of 6 in a unit of joule. Okay, 4.29 times 10 to the power of 6 joule. So where you're going to allocate these 2 marks, the first mark is in the substitution. Okay, when you substitute this formula with the correct value. Okay, mark 1 is given here. And mark number 2 is given in the correct answer with the correct unit given. Okay, 4.29 times 10 power of 6 joule. All right. Okay, class. Okay, let's move to the next question. Question C, 2C. Okay, find now the speed of the bulldozer at R. It say that the speed of the bulldozer at R is 0. So what does it mean? It means when it move upward, then it stop there. Okay, once it move from the below to the position of height, to the position of H, the bulldozer stop. That's why the velocity is, speed is 0. So calculate the height H of the bulldozer at R. So now how to find the height? Down, just now, down there, the speed is 35. Up here, it stops. So the speed becomes 0. So find the height of H. So Jinjie, this is where we use the equation for kinetic energy equal to mgh. So this is the energy changes, which mean the kinetic energy convert into potential, gravitational potential energy. So we write half mv squared equal to mgh. And since they are of the same mass, so m you can cancel off. So m we cancel off. So we have remain half v squared on the left side, and on the right side we have gh, where m is 35 for the kinetic energy and g is 10. So by this we can find the height h. So what is the answer? Cikgu Fairuza stay home. Thank you for being with us, Cikgu Fairuza. Okay, so h is 61.25 meter. Yes, very good. Okay, 61.25 meter is the height of h. Okay, class. Okay, now we go to question number 3. Okay, question number 3, they give you two diagrams, 3.1 and 3.2. It shows an image of a building seen in a glass ball. So this is the diagram 3.1. A man is holding a glass block, and you can see that there is an image of the building in front of him. Study the characteristic of the image carefully. And in diagram 3.2, okay, there is a container, contain water inside, and given the apparent depth is 3.25 cm and the real depth. Okay, real depth ini kedalaman nyata. Kalau dalam sebenar ini salah, kedalaman nyata. This one kedalaman ketara, apparent depth. Okay, 3.25 and the real depth is 5.45 cm. So what are the questions that follows? Okay, very simple. Question A. Name the light phenomenon involved in both 3.1 and 3.2. So, what kind of phenomenon involved here? What kind of light phenomenon involved in 3.1 and 3.2? Okay, you can share your answer in the live chat. Share with your others. Light phenomenon involved in both diagram 3.1 and 3.2. Yes, the phenomenon is refraction of light. Okay, refraction of light. Or you can say refraction. Okay, now move to question B. Okay, question B, state the characteristic of image seen in the glass ball. Okay, what is the characteristic of image you can see in diagram 3.1? Okay, I zoom the diagram for you. So what happened to the image according to the object? Yes, it is refraction. Yes, Jing Qian. Good. Aying, Arifa. Yes. How about B? Characteristic of image. So what can you say about the characteristic of this image? Remember, we have three types of characteristic. The first pair is upright or inverted. Okay, for lens. This is lens, right? Okay. And then either magnified or diminished, or real or virtual. But for this case, for real and virtual, we cannot identify because we don't know what is the focal length. So we don't know either the object is real or virtual. Unless you can draw the ray diagram, then only we can state either virtual or real. So for this question, you can state either it is upright or inverted, and about the size, magnified, diminished, or same size. So what can we say? It is diminished. Okay. Or you can say inverted, because this question only allocate 1 mark. So we say diminished, inverted. Okay. Yes, Vinci, inverted and diminished. Very good, Ayin. Okay, now question C. Based on diagram 3.2, calculate the refractive index of the liquid. Remember, class, how to find refractive index? Actually, there are 3 ways we can find refractive index. Okay, the first equation, n equal to 1 over sine C. Okay, that is the first way. Second, refractive index is given by speed of light in vacuum divide by speed of light in medium. Okay, and the third way is refer to this question. How to find refractive index when you are given apparent depth and real depth. Which one divide by which one? Apparent depth divide by real depth or real depth divide by apparent depth? Which one? So yes, it is n equal to real depth, write in capital D, divide apparent depth in small d. Dalam nyata bahagikan dengan dalam ketara if in bahasa. Okay, so we write the value given. Okay, so the apparent depth small d is 3.25 and the real depth capital D is 5.45 centimeter. So the refractive index is 1.68, no unit. Okay, 1.68. Okay, remember, if you are not sure with your answer, which one divide by which one thing you have to be very sure, refractive index, it cannot be less than 1. Okay, refractive index cannot be less than 1. It must be 1 and above. So let's say if you calculate, you get 0 point something, means your equation is inverted. Equation kamu terbalik. So you have to correct them. Okay, that is one tips to check your answer for refractive index. Alright. Okay, now 3D is the drawing on ray diagram. Okay, you are given a convex lens here, diagram 3.3, for you to draw to show how the image is formed. Okay, when you get this kind of question, remember you are not only have to draw the ray diagram, but normally you have to state together the characteristic of image produced. Okay, don't forget that. Draw the ray diagram correctly and determine the characteristic of image form. Okay, 2 marks for this question. Okay, how we draw a ray diagram for convex lens. They give you the first ray. The first ray is from the object passing through the optical center, so it won't be refract. It will continue travel in a straight line. So actually, there are 2 more rays you can draw. Okay, there are 2 more rays you can draw. The first ray, we draw a ray parallel to the principal axis. From the object parallel to the principal axis, heading towards the lens. So where will this ray refracted to? It will refract at the focal point. Remember, this is a convex lens. Convex lens is a converging lens, mean it must be converged. It must focus to a point after the lens. Okay, then, or you can also draw the third ray. The third ray is, ini the first ray you can write, you can draw. Second, you can draw a ray from the object cross the focal point at the front and it will refract parallel to the principal axis. So this is the point of intersection of all the ray light. Okay, all the ray meet here at this point, which means our image is formed at this position. So this is the second ray. So either you draw number 1 or number 2. You mark the position of image and write it as image. So this is the proper ray diagram which you should draw. Image. Label the image as well. So what is the characteristic of image shown here? Can you tell me the characteristic of image shown here? Upright or inverted? Now we can say virtual or real. And then look at the size. Magnified or diminish. So by this we say the object is real because it forms opposite to the object. Okay, opposite side to the object, and it is formed below the principal axis while the object is above, so it is inverted. Okay, and the size is smaller compared to the object, so we say it is diminished. Real, inverted, and diminish. Okay, the final image, real, inverted, and diminish. All right. Okay, next, question 4. Okay, question 4, it shows an instrument which is used to measure pressure of trapped gas in a container. So this is chapter 3, pressure, forces and pressure. Given the atmospheric pressure is 75 centimeter mercury. Okay, first, name the instrument. Okay, what do we call this instrument? To measure gas pressure. What is the name of this instrument which is used to measure gas pressure? It is called as, yes, this is what we call as a manometer. Okay, manometer is a device, instrument which we can use to measure gas pressure. Okay, then number 2, A2, state one reason why mercury is used in the instrument. Okay, we use mercury inside this manometer. Why mercury is always become a choice, always be a choice to place in a manometer. What is the reason of using mercury as a liquid inside the manometer? Yeah, this is because mercury, number 1, you can say mercury has a higher density. Okay, or you can say enable manometer to measure gas pressure using shorter mercury column. Can you imagine if we place water here, if you place water instead of mercury, how long the column should be? 1 atmospheric pressure equal to 10.3 meter water. Mean you must prepare a 10 meter long of manometer. Okay, 10 meter long of manometer. Can you imagine how is it possible to be used a 10 meter long manometer? Very difficult, right? So that's why we are using mercury, because mercury 1 atm only 75 centimeter mercury. Mean you only need 75 centimeter long of the column. So the column will be shorter and will be portable, easy to be moved from one point to one location to another. Okay, so this is the reason. Enable manometer to measure gas pressure using shorter mercury column. Okay, now question B. Based on diagram 4.1, calculate the pressure of the trapped gas. Okay, how to find the pressure of the trapped gas? Okay, first, this is an open end. Okay, and this end is connected to the gas tank. And you can see that the level of difference. Okay, on the left side, where the side that connect to the gas tank, the level is higher. On the right side, which is an open end, mean where the atmospheric pressure acting on is lower. So which pressure is higher, gas pressure or atmospheric pressure? Which one give a higher push? Which one give a greater push to the mercury? Atmospheric pressure. Okay, atmospheric pressure give a greater push to the mercury, mean atmospheric pressure is higher compared to the gas pressure according to this diagram. So how to measure? First, you must know what is the difference in length between these two levels. This will give you H. Okay, the difference in length in column on the left and the right side give us H. So how to determine the gas pressure? Atmospheric pressure minus H, minus the difference in length. So by this, atmospheric pressure given 75 minus 10. H is 10. 18 minus 8 down here. So the difference is 10. By this, gas pressure is 65 centimeter mercury. No gas bubble. No gas bubble, William. Normally that reason we place in a, ini jawapan selalu in a hydraulic system for a oil we are using in the compressor inside the engine. Why we are using oil? Because it has no bubble. But for this manometer, we talk about the density of the mercury. So you don't have to prepare a very long column of manometer. Okay, so the answer is 65 centimeter mercury. For this question, it doesn't state you have to place your answer in a unit Pascal. So you don't have to convert centimeter mercury into Pascal. So just leave your final answer in centimeter mercury. Okay. Okay, then question C. Now you're given diagram 4.2. The trapped gas is replaced by water and the mercury is replaced by liquid M. Okay. The result shown in diagram 4.2. Okay, diagram 4.2. The density of the water is given 1000 kilogram per meter cube. And then calculate the density of the liquid M. Okay. So how to do this question? Now, this column, we have liquid M, and up here we have water. And this is X and Y, which is at the same level. The height of water from X is 18 centimeter, if you look at this diagram. And the height of liquid M from point Y is 20 centimeter. So the question is calculate the density of liquid M. So how to do this if involve two types of liquid inside the same column? So what relationship we can make in between these 2 points X and Y? Since they are in the same level, so what can you say about their pressure acting on X and Y? The pressure acting is the same. So we say pressure at X equal to pressure at Y. So this is liquid. How to write pressure in liquid? Pressure in liquid is given by rho GH. Okay. So pressure X is rho GH for X. And pressure Y is rho GH for Y. Then we do the substitution. Okay, X is water. Y is liquid M. So water, the density is 1000, where G is 10. Actually, G you can cancel off. It's the same. Yeah, pressure is the same, Vinci. And H ini is the height of the water level above point X. It is 18 centimeter. Remember, H must be in meter. So you have to convert 18 centimeter has to be written in meter will be 0.18. Okay, and at the other side, density of Y we want to find. So G is 10 and the height of column above point Y is 20 cm. Again, in meter is 0.2. So by this, we can find the density of liquid M, which is rho Y. So what is rho Y? Please find rho Y. Okay, so rho Y is given by... Okay, so rho Y is 900 kilogram per meter cube. Remember, unit for density, kilogram meter cube. Water is 1000 and for liquid M is 9000 kilogram per meter cube. Okay, per cubic meter. Alright. Okay, that goes for question 4. Okay, now let's move to question 5. Okay, question 5 ini allocate 8 marks. Okay, 8 markah. Okay, you're given diagram 5.1 and 5.2. Actually, the same girl. Amina is jumping down from a chair to the floor without cushion. While in diagram 2, Amina jumping from the chair to the floor with cushion. So the difference between these two diagrams, first is jumping without cushion on the floor. Second, she's jumping with a cushion on the floor. She is landed on a cushion. Okay, A, define impulsive force. So class, what does impulsive force refers to? Impulsive force. Impulsive force refers to, yes, rate of change of momentum. the rate of change, sini ada of, I forgot the word of here, the rate of change of momentum. Okay, this is impulsive force. Rate of change of momentum. Okay, then question B. Amina, given her mass is 30 kg, jumping again from the chair to the floor. Okay. She moved from rest to 20 meter per second with different time of impact for both diagram. So this is the table you are given with. Yes, where you have to complete them. Okay, first, this is his motion, her motion in diagram 5.1. She is jumping at velocity 20 meter per second and her landed time is 0.03 second. And the impulsive force produced is 20,000 Newton. And in B, she is jumping with the same velocity, but now the time contact is 0.1 second. So find the impulsive force here. Okay, how to do this? How to complete the table? What formula to be applied? So just now we say impulsive force is rate of change of momentum. So this is her final momentum mv. This is her initial momentum mu, and this is the time. So rate of change of momentum. mv mass is 30, velocity 20, minus mass 30, final velocity 0. Why? Because she's already landed. So when she landed, she stopped moving. So final velocity is 0. Divide by the time. So time is 0.1. So by this, the impulsive force is 6,000. Yes. So we write, don't forget to write back at the table because they ask you to complete the table. So you must place your answer exactly inside the table. So 6,000 Newton. Okay. This is the solution. Formula, substitution, final value for impulsive force. And rewrite it back in the table. Okay, next. C. Now is a comparison. Remember question 6 and question 5 is a question on comparison. Compare the time of impact in diagram 5.1 with diagram 5.2. Okay, comparison. Is the time of impact the same or different? If different, which one is higher? Which one is shorter? Which one is lower? So first, you can state the time of impact. T, 5.1, the time of impact 0.03 second. 5.2, the time of impact is 0.1 second. So which one is higher, which one is longer? So which diagram is greater than which diagram? So this we can say, yes, diagram 5.2 greater than diagram 5.1. Or you can say the other way around. Diagram 5.1 less than diagram 5.2. Use the mathematical symbol. All right. And then second, compare the impulsive force in diagram 5.1 with diagram 5.2. Okay, from the table, for 5.1, the impulsive force is 20,000 Newton. And for 5.2, just now we calculated, it is 6,000 Newton. So which one is higher than which one? Obviously, you can see diagram 4.2 less than diagram 4.1. Or you can say the other way around. Diagram 5.1 greater than 5.2. As the first one, I started with 5.2 in front. So here I continue written 5.2 at the front. So later, easy for me to do the relationship. Alright, so number 3. Based on your answer in C1 and C2, state the relationship between time of impact and impulsive force. Okay, we go back to the diagram. So you can see when the time of impact greater, what happened to the force? The force will be lower. So time of impact increases, force decreases. So by this, I say time of impact increase, impulsive force decrease. Or you can simply say increase, decrease. That's all. Increase, decrease. Higher, lower. Okay? Opposite. Opposite jangan tulis. Okay, time of impact increase, impulsive force decrease. or simply say increase, decrease. Enough. Okay, D. Okay, this is a common question. I think you're also familiar with it. Why does Amina bend her knees when she land on the floor? What is the purpose of bending your knees when you jump from a higher position? What for? Yes, 2 marks. So how to get 2 marks? Number 1, you mentioned about the time of impact to lengthen the time of impact. So when the time of impact is lengthened, what will be the cause? Impulsive force will be reduced. To reduce impulsive force, so by then we can avoid injuries. Okay, class. Next, question 6. 6.1, 6.2. You are given 2 diagram. It shows a water wave passing through a log that floats in water. While in 6.2, a student standing at one corner of a building at B who can hear the sound from a loudspeaker placed at A. Okay, this is the 2 related diagram. Case first, 6.1, this is the direction of propagation of the wave. This is where the log at. And you can see this is the pattern of the water after it passed through the log. And in the second diagram, a boy is standing here. He can hear the sound coming from the loudspeaker placed on the other side of the wall. Okay, first, what happened to the water, to the wave after passing around the log and the corner of the building? So the wave that passing through the log, what happened to it? The waves, the sound wave coming from the loudspeaker after passing through this corner, what happened to the wave? To be stable is not accepted because it is too general, Arifah. Okay, because our concept apply in that question is impulsive force. So normally for impulsive force, there are 2 things you must consider. Okay, the purpose of bending knee is to lengthen time, untuk memanjangkan time of impact. So when the time of impact, we can reduce the impulsive force acting on the leg. So by that, we can reduce the chances of injury. Boleh kurangkan kecederaan apabila impulsive force adalah kecil. Okay, masa panjang, impulsive force rendah, kecil. So tendency to be injured will be reduced. Kecederaan itu boleh dikurangkan, the risiko. Okay. So class, what happened to the wave after passing around the log? Okay, you must know this is a concept refers to what phenomenon? So the wave diffract. Okay, we say the wave diffract. Gelombang dibelau or spread to a bigger area. Okay. Number 2, what happened to the amplitude of the wave after passing around a log? After diffraction, what happened to the wave after diffraction? What happened to the amplitude of the wave? Remember diffraction? Any changes on the amplitude? Amplitude refers energy. Okay, thank you. So amplitude of wave decreases. Okay, when the wave pass through a gap or pass through a barrier or an obstacle, its amplitude decreases. Mean the energy decreases. Okay, so amplitude decreases. Name the wave phenomenon that is related to both diagram. I just mentioned you the phenomenon now. It is. Before that, the first question on top, number 2, they ask you to explain first what happened to the amplitude. Why? So amplitude decreases. Why? Because energy of the diffracted wave decreases. Okay, and the phenomenon is diffraction. Pembelauan if in bahasa Melayu. Okay, diffraction. Okay, next class, question number 4. What will happen to the speed of the water wave after passing through the log? Any changes happen to the speed? Amplitude decreases. How about speed? Okay, what do you remember about diffracted wave? Was the speed changes after diffraction or remain the same? If changes, increases or decreases. Speed of wave after passing through the log. If we are talking about speed, you must refer to the wavelength. Does the wavelength change after diffraction? Change or not? The wavelength doesn't change, right? Only the pattern change, but the wavelength does not change. So by this, the speed remain the same. It is unchanged. Okay. Next. Okay, B. Okay, now we focus on diagram 6.1. What will happen to a floating object that is placed at P and Q? Okay, we place two objects. P is placed near to the log and Q is placed here at the center. Okay, you see here there is no wavefront. Okay, P is placed at the wavefront. So what will happen to P? What will happen to Q? What happened to the floating object? So what will happen to P? P will move up and down. Or we can say P will vibrate or oscillates. How about Q? Okay, Q will be stationary. Okay, Q is stationary. It float there stationary. Okay, dia tak gerak sebab you can see in this diagram there is no wavefront produced there. Okay, mean the water there is calm. Okay, while for P, it is at the wavefront, so it will oscillate or vibrate up and down. Okay, other than diffraction, name one other wave phenomenon occur in diagram 6.1. Okay, so what kind of phenomenon other than diffraction? Okay, so it is reflection. Okay, reflection, when a wave travel, it bounce on a surface. So when the wave bounce on the surface of the log, it will be reflected. The wave will undergo reflection, change and decrease. I think you refer to the velocity. The velocity is constant, Arifah, because velocity refers to the wavelength. For diffraction, the wavelength is not changes. Only the pattern changes. Bentuk dia saja berubah. Tapi jarak gelombang dia tetap sama. Which means the speed also remain the same. Okay, for diffraction. Okay, class. Next, question 7. Okay, we have 2 more questions to go. I try to go a bit fast. Okay, 7.1. Spring. Now, Hooke's law. Okay, state Hooke's law. Class, what do you remember about Hooke's law? 7.1, there is a load hanging on spring M. Okay, so what is Hooke's law? So Hooke's law refers to the force that acts on a spring. It says that force acting on a spring directly proportional. Proportional to what? Proportional to the extension of the spring, provided that the spring is not stretched beyond its elastic limit. So there are a few keywords you must insert here. Number 1, force. Directly proportional. Extension. Elastic limit. Not stretched beyond elastic limit. Okay. That is Hooke's law. Okay, then number 2, calculate the spring constant of the spring M when the extension of the spring is 4 centimeter. So what is the formula to determine spring constant? So we can apply F equal to Kx. This is Hooke's law formula. F is the force, K is the force constant, and X is the extension of spring in a unit of meter. Okay, F is Newton, K Newton per meter, the SI unit, and X is in meter. So you just do the substitution. Force is given by the weight of the load hang on the spring, 1 kg. So 1 kg mean the force is 10 Newton. Okay, the weight 10 Newton. Okay, we want to find x is given 4 centimeter. Extension in meter is 0.04. Don't forget to convert into meter. So by this, the force constant of the spring is 250 Newton per meter. Okay, 250 Newton per meter. Always give a proper solution. You started with formula, substitution, final answer with correct unit. Alright. Okay, then B. Spring M breaks when it hung with heavier load of 3 kilogram mass. Suggest a modification that can be made for the following aspect to able to withstand heavier load. Okay, so you can highlight to withstand heavier load. Okay, so mean in your answer, you don't write to withstand heavier load as the reason. Don't use the same phrase. Change it with another word which bring the same meaning. Okay, stiffness of the spring. Want to use a high stiffness or low stiffness? Stiffness must be high or low. For spring, we choose a string with high stiffness. Stiff. The spring is stiff. Why? So it will give a high spring constant. So it can withstand a big force. See, withstand heavier load now is changed to withstand big force. And the spring will be hard to stretch. Okay, so the spring is stronger. Okay, boleh tulis strong. Also accepted reason, strong. Okay, second, thickness of the wire. Okay, which thickness give you a strong spring? Thicker or thinner? Thicker or thinner? Remember when we learn Hooke's law, we choose a thicker spring, thicker wire. Why? So that it can withstand a big force. Again, it will give you a high spring constant. Mean the spring is strong. Okay, and type of material. Okay, what type of material is suitable to make the spring? You can say steel. Okay, steel spring. Use steel spring instead of copper steel or iron steel. Kita guna steel. Remember, steel is an alloy. Why? Because it is strong or it can withstand a big force. Okay, so this is the modification can be done in enable the spring to withstand a heavier load. Alright? Okay. C. Now, identical spring N is hung together with spring M. Okay, spring M and M, they are identical. The same type of spring. Same length, same material, same thickness, same spring constant. Okay, identical. Draw the arrangement of spring that can hang heavier load without breaking the spring. So we have two choices of arrangement. How do you want to hang M and N? Hang them in series or hang them in parallel? Okay, in series mean one on top of another. Hang M and below is M. Series. Okay, hang them in one line. Or better we place them in a parallel arrangement. Which one do you think is a better arrangement? Series or parallel? So, answer is yes, parallel. We hang them in a, yes, Ginger, very good, in a parallel arrangement. So by this, the load will be spread equally in both spring. So it can hold or withstand a greater force or heavier load without breaking. Yes, parallel. Good. Okay, now we have come to the final question 8 for today. Here we have electromagnet. Okay, diagram 8.1. It shows an electromagnet. Based on this diagram, name the rule used to determine the direction of current flow in the solenoid. Okay, what rule we can apply here to determine the direction of current in the solenoid? Okay, this is the circuit connect to the solenoid. So current flow in this direction. Okay, so it flows to the solenoid. Okay, so what law, which law we can apply here? Again, yes, we apply right hand grip rule. Okay, right hand grip rule. Okay, now switch is turned on. Current flow through the solenoid. State the magnetic pole at X. Okay, I want you to look at the diagram clearly in which direction the wire is coiled at. So current flow in this direction. Okay, tengok dia punya coil ini how. Okay, so X is south pole. So how we hold this solenoid, how we apply right hand grip rule. Okay, so you can have your pen to show the solenoid. So X is above. So when you grip the solenoid, okay, current flow, it flows in a clockwise. Okay, current in the solenoid flow in a clockwise rotation. So we place our curl finger in a clockwise rotation, which means your thumb will be pointing downwards. Okay, thumb is pointing downwards, which means down of the solenoid is north. Above solenoid is south. So point X is above, so X is south pole. Alright. Okay, and now question 3. The battery terminals are reversed. Okay, now we reverse the terminal of the battery. Mean now current flow in this direction. Okay, current flow in this direction. Now it flow anti-clockwise. So it flow anti-clockwise. So now we hold the solenoid. Our curl finger is in anti-clockwise rotation, which means our thumb is now pointing upwards. So upwards is north. X is now north. Okay, so the answer is X is now north pole. Yes, it is right hand grip rule. Number 2, X is south pole. And number 3, when we reverse the terminal of the battery, X will become north pole. Okay. Okay, next. Okay, B. In diagram B, now we have can you tell me the name of this string? It is used to lift scrap metals. Okay, what is the name of this thing in this picture? It is used to lift scrap metal. So we call it as a this is a scrap yard. All right. And this is the internal structure. And you are given a table of choices. You are given 4 types of electromagnet, W, X, Y, and Z. And 3 characteristics are given. The type of core. W use soft iron. So do Z. X use a steel as the core, and Y use aluminium. And this is the magnetic pole inside. This is both north. So same polarity. Both north. For X, it is in the middle is south and outside is north. So they have opposite polarity. For Y, it has the same polarity, both as inside and outside. While for Z, it has an opposite polarity. At the center is north and outside is south. Okay, so X, we say W and Y has the same polarity. X and Z has a opposite polarity. And this is the number of turns given for each. W and Y is less. X and Z has more number of turns. Okay, so what is the question? Based on table 8, state the suitable characteristic of electromagnet to leave more number of scrap metal. So our aim is to leave more number of scrap metals. And give one reason. So type of core, which one is a better choice? Normally when talking about core, so we choose soft iron core. Yes. So what is the reason of choosing soft iron core? Because easily magnetized and demagnetized. Okay, very good. Okay, next. magnetic pole. So the magnetic pole, better to be same pole or opposite pole? Which one do you think? The magnetic pole, better to be same or better to be opposite pole? So the answer is, we choose opposite polarity. Yes, soft iron, Wei Lun. So we choose a pole of opposite polarity. Why? So opposite polarity will cause the attraction, force of attraction. So it will give a stronger magnetic field strength. Stronger magnetic force will be acting on the scrap metals. Okay. And number of turns. So number of turns, which one is a better choice? More number of turns or less number of turns? They give you two choices, less or more. Yes, opposite pole, Jinjay. Reason is to provide stronger magnetic force or magnetic field strength. So number of turns. Yes, more number of turns. Why? What will happen to the magnetic field strength when there is more number of turns of coil? So the stronger magnetic force will be produced. Or you can say stronger magnetic field strength. Stronger magnetic field. So all this reason will bring us so it can leave more metal scraps. Okay. And question 4. I think this is the last question. Question 4. Based on answer in B1, B2 and B3, choose the most suitable electromagnet to leave more number of metal scrap. So which one is a better choice? W, X, Y and Z. Just now we choose soft iron. So soft iron, so it is either W or Z. Okay, opposite polarity. Opposite polarity. So which one is opposite polarity? X and Z. So there are 2 votes for Z. And then number of turns, we choose more. So this one X and Z. So we have 3 votes for Z. It fulfill all 3 characteristics. So which mean the most suitable electromagnet will be Z. Okay, so we choose Z. It is made of soft iron, opposite magnetic pole, and it has more number of turns. Okay, C. Now question C. Okay, this is the last question. In diagram 8.2, the electromagnet can lift 1,800 kilogram mass to a height of 8 meter. It can lift 1,800 at a height of 8 meter in 4.5 seconds. Alright? So calculate the output power generated by the electromagnet. Okay, how to find output power generated by the electromagnet? They give you mass M. This is height H, 8 meter. And this is time 4.5 seconds. So we want to find power P. So how to relate P, M, H, and T? So what formula we can apply to find the output power? Yes, power is, remember what power refers to? What is meant by power? Power means rate of work done. Okay, or rate of energy use. In this case, it involves gravitational potential energy. So mgh. So rate of gravitational potential energy mean gravitational potential energy divided by time. mgh divided by t. So m 1,800, where g is gravity, 10, and height is h, 8 meter. The time is 4.5 seconds. Okay, so by this, you will get the power generated by the electromagnet is equal to 32,000 joule per second. Okay, energy is in joule, time is per second, or you can say 32,000 watt. Okay, 32,000 joule per second or 32,000 watt. Okay, class. So what do you think of today's question? What do you think overall? What do you think of the question in section A? Was it tough? Or is very easy? Or too difficult? Okay, remember this is the spotted topics for this year SPM. Spotted mean does not necessarily this is the one that we come up. We have another different set from different states. So I'm trying to collect them and we are going to discuss them in the next lesson. Okay, so far I have from 2 or 3 more states from my friends. So later I share them with you in the next lesson. So for next class, next Wednesday, I want you to try the essay question on section B and section C first. If possible, you don't refer to the answer first, which I give you earlier in my Telegram channel. But just now, today I delete the answer first. So I want you to try first. And next Wednesday, we discuss about these two, section B and section C. And when we finish, then we proceed with paper 3. So for today, thank you very much for your cooperation. Thank you very much for your commitment. I'm sorry because we are a bit delayed just now due to my technical problem with my lappy. So I think that's all for today. If you have any further question, you can PM me in my phone. Okay. So see you again next week. Again, thank you very much. You do take care. Stay healthy, stay safe, stay at home. Okay. Till then, Assalamualaikum and a very good evening to everyone. See you again in the next lesson. Bye-bye.